Hello and welcome to the next Shell Eco Marathon virtual learning session with Altair Engineering. My name is Norman Koch and I'm the Global General Manager of Shell Eco Marathon. I want to thank you all for your flexibility and understanding as we evolve the Shell Eco Marathon program due to the impact of COVID-19. But as this situation continues to change the safety and health of our Shell Eco Marathon participants, and of course our organizing teams, remains our top priority. Given this current status, we are so excited to have you all with us in this new digital environment to kick off our virtual learning sessions, all from the safety of your homes. Today, you'll be hearing from Eric Larson from Altair Engineering about fast meshless analysis. Altair is a global technology company that provides software and cloud solutions in product development, high-performance computing, and data analytics. Altair supports Shell Eco Marathon by supplying licenses, training, and support for Altair HyperWorks to the teams competing in the Shell Eco Marathon events. Eric is a technical account manager for education at Altair, and he has been working there for over 13 years. He studied mechanical engineering at the Michigan Technology University and has 30 years of experience in product design and analysis. So welcome, Eric, and we look forward to hearing from you in just a few moments. But before we get there, just a couple of housekeeping details. We would like to make the session, of course, as interactive as possible. So if you have any questions throughout the presentation, please go to the website menti.com on your browser and enter the code shown below on the screen. On Menti, you will be able to post your questions, see others' questions, and give a thumbs up to those questions that you think are important to answer, so they rise up to the top in the queue. If by any chance you have any issues accessing Menti, you can also post your questions in YouTube comments on the right of the live stream once you're logged into YouTube. Eric from Altair will then be answering your questions after the presentation portion of this live stream. And please, this is your chance, come up with really good and tough questions to put Eric to the test. As you know, this is a live video stream, so if for any reason we run into technical difficulties, please be patient and bear with us while we sort out this issue as quickly as possible. I think that's all from me. I'll hand over now to Eric from Altair, who will officially kick off the session. Eric, it's all yours.
Thank you very much, Norman, and I appreciate the kind introduction. I'm Eric Larson from Altair, and just briefly want to talk to you about our involvement with the Shell Eco Marathon. We are happily celebrating our 4th year as a partner and a sponsor for the Shell Eco Marathon. But even before that, for years, we have supported Super Mileage and pretty much any competitive design team by providing corporate software sponsorships. The software is free. It's the same level license that our customers get, and we're happy to help you out. In addition, we do sponsor a vehicle design award and have provided support to numerous teams through the years. With our CFD, our structural and optimization offerings, we're a great fit with anybody looking to improve vehicle performance on their design. So I'm not going to bore you with any slides. Going to get straight into the software. SimSolid is the software that we're talking about today, and it is a meshless geometric-based analysis tool. And I think you're going to find it's very, very easy to use, gives you amazing results very quick. And hopefully by the end of this, I'll have provided you enough information to get going on your end. And then at the very end of this, we'll discuss how you can go about getting a sponsorship through Altair. It's another easy process. So without further ado, let's talk about the software. So this is the SimSolid interface. Very simple, very easy. And the first step to utilizing SimSolid is, of course, to bring in some sort of geometry. SimSolid is a preprocessor. It is the analysis tool and the post processor, but it does not have any geometric capabilities on its own. All of your geometry work is going to be done in whatever your favorite CAD system is. And as you see here, if I come to import from a file, I'm going to be opening up this drone body step file, but just quickly let me show you here. You're going to see all of the popular CAD packages there, whether you're talking about CATIA, Inventor, ProE, SolidWorks, UG. We do support import of the native CAD files, but in the event that you're using something other than these, or you're having some difficulty, we also support the intermediate formats of Parasolid and Step, which do a fabulous job of bringing in the geometry as well. So no matter how you have your files, we'll be able to bring it directly into SimSolid. So the geometry work is done in the CAD. As soon as you're ready, you bring the geometry into SimSolid by just selecting that file, and we're going to get our file here. Now, this is a drone body. We'll get into that in just a second. But the very first thing that's going to happen when we import a file into SimSolid is this little wizard, this connection wizard is going to pop up. What this guarantees is no matter how many parts you have making up your model will be considered one contiguous entity. So everything will be connected together. As you see here, it's automatically calculating both gap and penetration tolerances. Gap is going to govern how far any two solids can be before it starts considering them separate. So anything under 1.1165 millimeters, it realizes that there's a little bit of potential slop, a little bit of problems that may arise in your CAD file. So it will take those two solids and it will merge them together. And then penetration is when solids are going in the other direction, when they're actually penetrating each other, overlapping each other, and anything below a bit above half a millimeter, 0.55825. It will take care of that and consider them bonded as well. Beyond that, well, then we're getting into the realm of problem geometry and really something that needs to be taken care of on the CAD side. Though these values, these tolerances can be edited, and we have the ability to change the resolution here. But in general, what I would suggest is leave these alone, leave it on normal, import it in, because as soon as we do that, then we can go and inspect the connections that it made and make sure that we've got all of the connections. So now that we have the model in here, and we'll get to the assembly and connections in a second, but now that we have the model in here, we'll take a look at that geometry. And as you can see now that I'm rotating it around, this quite obviously is a body for a quadcopter, a drone, whatever you want to call it. And you'll notice that as I click things around, this is made up from a large number of different solid bodies. But because of that automatic connection wizard, all of these are connected together, and we'll review those in the connections. But before we do that, it's probably best just to talk a little bit about the interface so you can become familiar with that. It's a very, very easy to use interface. The first thing, of course, is how do we manipulate the model? How do we rotate it, pan it, zoom it, all of that sort of fun stuff. And SimSolid, of course, has its own way of doing it, and the way that we do it by default in SimSolid is the left mouse button is going to provide you a trackball style rotation. So as I rotate it here, I left clicked and I'm rotating that. If I come over to this side and rotate, it kind of rotates around this side. So we can get our model into whatever orientation we want it to be. To pan it, I just hold down the right mouse button and I can drag it around the screen. And then this scroll wheel pushing the model away or pulling the model into you. And you'll see whatever I hover the mouse over, that becomes the point of interest for the zoom, either in or out. So what I typically do is I'm interested in this foot right here. I'll hover my mouse over that and I'll just kind of drag it toward me, maybe then center it, and I'm good to go. Now, anyone who's used multiple GUI-based systems, CAD systems, FEA systems, they understand what I'm about to say. A lot of times it could become very, well, not difficult, but it becomes challenging to move from one system to another. You're used to left-clicking to rotate and right-clicking to pan, and suddenly the new system uses the exact opposite or something even potentially more difficult. And you're fumbling around with keys and it's not doing, or mouse buttons, and it's not doing what you want it to do. Well, we want to make that as simple as possible, make that transition as simple as possible. So all you have to do is come here to the settings, and you'll see in here mouse settings. The default mouse type is, of course, SimSolid, and here's a description of what I just explained. But if I select this, you can select any of these supported CAD systems, and it will alter the mouse functionality to match that CAD system, making it a seamless transition from your CAD system into SimSolid. And like I said, if you've used multiple systems, you know what I'm talking about, and you understand that this will make it much, much easier to move from one to the other. Another aspect or another feature we have here in settings is the geometry import settings. When I select that, that's going to govern how the next model is imported in. Or if I had done this before I imported this model in, it would have done it on that model. We have the ability to set the resolution. And that's really just how it interprets the geometry and then writes out the database into SimSolid. I quite honestly have never moved it off of standard, but my understanding of it is, especially when you have in one model very small objects and very large objects, and you've got a large range of kind of orders of magnitude, by changing it to enhanced fine or custom, we can alter those deviations and quartile deviations, and we can get a cleaner model in. But also, like I said, I have not removed it off of standard, and it's worked fine for me. The other important thing to note is we do import materials with this select, and it is selected by default. We import materials from CAD systems that support the definition of materials within the CAD system. So if your system does, make sure that this is selected before you input, and it should be. And then when you import it in, the material will come along with it, and everything should be predefined. And you'll notice with the assembly, all of the names of all of the parts that were defined in my CAD system are still there. And then you would find the material after that, and we'll get to material assignments in just a moment. But first, I want to address the connection. So I said that this did an automatic connection. It looked for tolerance, or it looked for parts that were close to each other. So imagine, these two parts, this part on top, this top plane, and this part of the arm right there. They are in extremely close proximity, if not perfectly touching. And if we come here and review the connections, if I highlight connection 1, it puts my model into transparent. It colors both of the entities, both of the solids that are connected together, in this case, the lower part of this arm and the upper plate. And it shows me that it is perfectly following the outline of both of these, and these little red dots indicate the connection. So I know that those two solids are perfectly connected together, and I could come through and I could review each and every different connection, all 85 of them, all the way down to my fasteners that are going through tubes and sleeves, to the connection of the arms themselves. And I could do that. But quite honestly, I have had such success with connections within SimSolid, I don't even bother with that anymore, because it does a fine job of creating those connections. And because it's so quick and simple, I could run an analysis on this and discover a problem in less time than it would take me to go through each one of those 85 connections. So you have the ability to visually verify them, but you don't have to. The next thing I want to talk about is the assembly of the model here. So as I was showing you, we can left click to select individual pieces, and they will highlight in the browser here, or I can left click on the parts in the browser and they will highlight on the screen. Another visualization mode that we have, one that I'm particularly fond of, is this visualization mode right here. It says show parts in random colors. So I turn that on, and what it does is it just randomly colors each one of the parts, and it kind of allows you to get an idea of the scope of your model, the number of different parts you have in it, how it's set up, what's in the same part, what's in different parts. And while there may be a repeat of colors, at least I can tell, okay, this is a different color from this, which is a different color from this, and so on. And I can see kind of the general shape of my model. If I want to view my model in wireframe, I can come up here and click this, and that gives me a wireframe view, or go back to shaded, and then I have the option of turning on or off the wireframe, the edge of the geometry as well. I prefer it off when I'm in a shaded, but your views may vary on that. This right here shows my parts in a transparent mode. So just like we did with the connect view, this puts all the parts in transparent, lets me view all of the different parts there, and kind of review of the entire model. And then last but not least, clip assembly plane. This will put a clipping plane on here, mounts it right at the top of the part, and if I hold my control key down and I scroll my scroll wheel, I can move that plane up and down. And if I hold my control key down and I left click rotate, it will reorient that plane so I can clip through my model. If I kind of get it into a position where it just becomes difficult for me to get it back to where I want it, I just turn it off, turn it back on, and it defaults back to a horizontal plane. So let me turn that off. Now I showed you can click to select. You can also do the standard control click where I can add things to the selection. Additionally, we have a box selector, and that's found with this little option right up here. And the really cool thing about the box selector is if I box select, so hold my left mouse button down and drag a box from left to right, you see it grabs everything that box touches, or at least gets a portion of it in the box. But if I drag from right to left, there we go, it only selects entities which are entirely within the box. Really useful feature. Say I wanted to box select, well, I need to get out of box select to rotate it. So these 4 bolts representations right here, I want to select those. It would be difficult. I'd have to manually click them or box select and hide things. But the neat thing is with the right to left, if I do that right to left and come like this, even though I'm nicking other things, it just grabs those bolts. So that's a really useful feature for box selecting. Okay, so now let's get over here into the project tree. And the project tree is really the heart of SimSolid and where a lot of the power of SimSolid lies. And that's, we treat every model as a project. Yes, you may bring this in and you may just do kind of a one-off analysis on it. But some of SimSolid's greatest power is the fact that it treats it as a project. And in a project, we typically go through multiple iterations, maybe some design revisions. And the nice thing about the project is we can keep track of all of those all the way down. And as you're going to see as we get into the more advanced things, it's a really amazingly useful feature that it has. So the first thing that I need to do, right now I just have the assembly and connections under my project. First thing I want to do up here is I want to come up here and set my units. My units are defaulting to SI. And when I come to select this ruler, I can see what units are being used. Millimeters, velocity is going to be in meters per second, acceleration meters per second. So it allows me to kind of vary things, which is nice. If I'm taking measurements or setting things up, oftentimes I like that in millimeters, but millimeters per second is a really inconvenient way to reference velocity. So it allows me to mix up my my reference units within the SI or the IPS and keep them kind of convenient. I'm going to work, of course, in SI. Now, back under, and the default material, I don't have a default material specified. I typically don't use a default material. I like to just assign things on my own. And that's where we need to go now, because before I do anything, I need to give this model some material definition. I just brought in a step file. There was no support for material in the geometry import in that case, so I need to define it manually. And defining materials is amazingly easy. I just come to my assembly. I'm going to come up here to my material icon, and I'm going to get a list of the material library that comes along with SimSolid. The first of which are as you can see here, we've got generic materials, carbon, alloy steels, stainless steels, cast iron. So we get these groups, and then within the groups, you're going to get a whole selection of different and common material definitions. We also can add materials to this, and I'll show you how to do that in just a second. But in this case, I'm going to imagine that I 3D printed this entire quadcopter here. So I'm going to come down here to my plastics, and I'm going to grab ABS plastic. That's a good 3D print, high-strength 3D print material. And then I'm just going to come down here, click this button, apply to all parts, and you'll see in my project tree here, now all of the parts list ABS plastic next to them, so I know that ABS plastic has been assigned. Now, say for instance, I said, okay, that's great, but maybe these hexagon socket head cap screws, I don't want them to be plastic, so I'm going to come here, I'm going to highlight those. You see they're highlighted on I missed 4 of them, but that's okay for this demo. They're highlighted in the graphics window, and now I can come up here to say stainless steel, and I'll say these are annealed 302 stainless steel. And now, as opposed to apply to all parts, I apply to selected parts. We don't see anything happen here because I need to expand this out, but you'll see now Once I get it far enough out, all of my hexagon socket heads are stainless steel. So assigning materials is also crazy easy in SimSolid here. Now, if you have your own material, this is a pretty extensive list of materials, but you've got your own materials here. We want to apply those. I just come to my settings. I'm going to come to material database. I'm going to edit the current database. And once I'm in here, a material needs to be added to a group. So I created this material group 0 down here, and I could rename it. I'll just call it custom materials. And if I wanted to, I could add another group. And I see I put this dummy material in here. So I highlight my group, and once I'm in there, I can add a material. I can define it however I want in SI or IPS and just come through and add all of the values here. So I just add some values. It actually, so in my last demonstration, I put a ridiculous number for Poisson's ratio, and it called me out on that. So we'll make sure we get a good one there. And then I just click, give it a name. We'll call it dummy 2. And I click Save Material, and now I have my own custom material in there. And when I come to my material list, I can select that and assign that as well. So if you have your own material definitions, by all means, add them in that library. That library is going to stick around. It's not just a one-off deal. It's saved along with the software, so you will always have access to that those custom materials that you put in your library there. Okay, so easy as that. Now my model is ready to start analyzing. That's all I had to do. It automatically connected. I assigned materials. I'm good to go, and that means I now need to add a analysis to this, or some sort of study I want to do. And those are handled by these icons right here. The first of which is my linear structural analysis. And if I select that, I'm going to do a structural linear. We can also do structural nonlinear. It's a bit more complex, so we'll just stick to structural linear in this. It's going to add an analysis to my study here, which is my baseline study. And I can alter my solution settings, lab for stiffness, some of the other ones are going to have options in here. And then all I need to do is come along to here, and I get all of the icons necessary to define my my solution. So I get my constraints up here, or my support. So this is an immovable and encostra constraint, a sliding constraint, a hinge, spring support. Then I come to my forces, my pressures, my force, gravity load, inertial load, all of those things there. So I'm just going to do a simple analysis here, simple linear static, and that's going to require an immovable support. So it pops up the little immovable support window, and I can apply that to a face, an edge, a vertex, or a spot. So I'm going to apply this to a face. And what I'm going to do is I'm going to come to the bottoms of all of these legs here, and I'm going to select that. As soon as I select it, it puts that face into the window there, and I'm going to move on to the next one. Select that. And with each selection, it highlights the one I just selected. I lost that selection there, but that's fine because it's just indicating the immediate one I selected. The previous one's still in my my queue here. So I'll select that and select that, and now all 4 of those faces are there. All I have to do is click OK, and you see I have the option of adding tangent faces as well. I click OK, and it puts these little yellow markers on here. These little yellow X's are indicative of an immovable support. So now I know, turn my model over like that, this thing's not going anywhere. It's as if it's sitting on the ground and it can't move. So perfect, I've got the static portion of my linear static. Now let's put a force on there. And to put a force on there, actually, let me turn on the edges, because you see I've defined a little box here, and we're going to imagine that that box represents the extents of maybe a camera or an electronics package or something sitting on top of there. And I want to simulate that pushing down on my quadcopter. Maybe we've come in for a really hard landing, and that's going to be putting a force down on there. And I've calculated that force, or estimated that force, to be 100 newtons. So I'm going to come here to my force displacement, and select force. And with my force displacement, I can either enforce a displacement on here. So I could say, well, I don't know what force it is, but I know this deformed 5 millimeters. And so I could put that on there, or what I'm going to do in this case is a force. I'm going to say I want to put that on an edge. And all I have to do is pick that edge right there. So it's grab that entire square around there. And now I can come here and tell it I want to put a force. Take a quick look at my triad. It looks like I want to be in the negative z direction. So I just come down here to my z, put in negative 100. Click OK. Doesn't look like it did anything, but when I peek underneath it, because this is in the negative direction, those arrows are going to come down. So now I've got 100 Newton force on there. And that's it. I'm ready to go. Had I not been talking, could have had this completely ready literally in about a minute. So the only thing I have left to do now, while I'm in my structural here, and I can, you see, I can always review them. In my structural, I come down here to my run icon, click that, and as quick as that, we're done. That analysis took 6 seconds. 6 seconds to get a full structural analysis. So we're going to add that minute of prep time that I could have accomplished. And we can honestly say that in 1 minute and 6 seconds, I went from a completely blank screen to a ready to review structural analysis. That is a claim that cannot be made by any other software out there. And then I come here to my result. I can come to my result and it gives me a list of all of the possible results that I have. Grab displacement magnitude. It's going to show me a contour of the displacement. I'm going to get a list of my displacement legend over here. I can animate that. Let me turn off that wireframe. You see that wire kind of shows me my zero, which can be useful, but right now it's just in the way. And now I get this. Now this animation is scaled up. This is not the bending that this would see from a mere 100 Newton load. We scale it up because if I come here and look at my deformed shape, you see I have the option of altering that and really scaling that up. But we scale it up because if I were to click that, which shows the true deformation, basically takes it to a scale factor of 1, doesn't look like it does anything. And in fact, I really have to zoom in here to see any movement whatsoever. And while that's the true movement, it really doesn't help me understand the behavior of this. So we take care of the problem of auto scaling it up for you so you can see the general behavior. So don't worry about the fact that it doesn't look totally realistic. Additionally, I can change how I'm coloring it, contouring it. I can go to a 6-color display. What I prefer, the 12-color display. Or I can go to smooth colors where there's going to be no lines between it. We get a nice smooth dithered effect, but I do like this. Additionally, I can show max and min. So this is going to highlight where the max of my display and the minimum of my display are. And then I can change things like the speed or the number of steps. So you see this is very jagged and this is smoother. Really, the only time I ever change these, I change the speed every once in a while, but the only time I change this is when you can get a complex model that is really kind of struggling, and we can reduce the steps and make it move a little faster. So okay, so that's my displacement, and what I want to do here is I'm going to come down here and I'm going to click this little camera. It says snap bookmark. And I'm going to do that because one of the great things about about SimSolid is the fact that we can save these bookmarks, and when we get into design studies, it's going to make comparing things insanely easy. But we'll get to that in a minute. So I need to come here. I want to take a look at my von Mises stress. So stress obviously is very important. There we go. We're not getting a lot of stress out of this thing. Oops, there we go. And I'm going to come and I'm going to take a snapshot of that as well. Excellent. So now I have all of my information here, and I'm all set with my first study. So I know my stresses, I know my displacements. I'm I'm good to go. I know where I stand. And what I gather from this is, since we're not getting a lot of stress, not getting a lot of displacement, I maybe can make some changes to it. And in anything in aviation and drones especially, weight is everything. Weight is battery life, weight is flying time, weight is lifting capacity. So I've made in my CAD package, I've made a bit of a change to this. And what I want to do is I want to compare my current results to that change that I made. So I'm going to come here and, I'm going to walk that back for a second. Before I do that, I want to do two more analyses on this. The first of which I want to do is a modal analysis. So a modal analysis is going to tell me my frequencies. I'll click OK. Number of modes 9. I can edit that. I can make it as many as I want. We'll bring it up to 12. And I'm going to run that modal analysis. Again, the modal analysis, really quick. This one lasted 4 seconds. And now I can review the results of my modal analysis. So this is my displacement. So I can see those mode shapes. And I can see the frequencies at which it's vibrating and how it's vibrating. So that's done. And I'm also going to do a thermal analysis. So maybe we're going to assume here that we've got, so come to thermal, maybe we're going to assume that we've got a high temperature here. So our camera, our electronics package is getting pretty hot. I'm going to apply that to that face, and we're going to say it's 100 C. So getting fairly hot. And then maybe we're getting a little flux, a little cooling off the bottom. So I'm going to add some flux here. And I'm going to grab that face there, and we're going to say we're going at -50 watts per meter squared. And so I've got that. Now I can come here, run my thermal analysis. And very quickly, I've got my results. So I can take a look at the temperature, see how that spreads out, see how that's working there. And I can contour thermal flux, see how the flux is going, temperature gradients. So we're getting some pretty serious gradients there. So I can look at all of these results, and I have all the information about my thermal. So very, very quickly, I've got three, not entirely complex, but three slightly complex analyses under my belt, and I know a lot about my baseline. But as I mentioned, I made some changes. So what I'm going to do now is I'm going to come here to Project. I'm going to come to Import from File. And I'm going to grab my modified version of my drone. I'm going to click Open, and it's going to bring that into my current project with the same connection tolerance. So I'm just going to allow it to auto connect. So now I've got this. It's not its own new project. It's in the same project that I had before. And because it sees such a similarity between my baseline and my new analysis, it knew enough to go and create all three of my analyses in here. My structural. You see, there's my constraints. There's my force. And you'll see, I probably should show you here. This is my change. This was the original arm, and I went and made these arms thinner, save a little weight. But everything else was the same, so it knew how to recreate each one of these. My modal, my thermal, and my structural were all recreated. So all I have to do is quickly run them again, and I've got results for my brand new model. And the only thing I have to do is any geometry that changed, you see, no longer has a material to it. Because I changed the geometry, it didn't go and auto assign. I could have had it auto assign, but again, I like to kind of keep things manual just so I can make sure I'm getting exactly what I want. So I'm going to window select those two. I'm going to hold my control key down and window select these. Those are the 8 things that don't have a material. So I just come up here to my material, come back here to my plastics, grab my ABS plastic, and apply to the selected parts. And doing selected means it's just going to put it to those 8 parts, and it's not going to mess with that steel revision that I did to my to my what do you call them, fasteners on there. And that's it. Now it's ready to run. All I have to do is click structural, click run, click modal, click run, click thermal, click run, and in what, 30, 40 seconds, I've gone from my baseline study to a complete and total duplicate study on my modified part. And the really cool thing is, because I bookmarked my original study, all I have to do is come here to that bookmark. It brings up the original study. And now if I come to my structural results in my second study, it takes those exact settings that I have, the exact configuration, and applies it. So now I get a direct one-to-one comparison. I can see in my original study, my baseline, I was at 0.49, so we'll call it half a mil displacement. And now I've jumped all the way up to almost 2 millimeters of displacement. So a substantial increase in displacement, not surprising because I made these changes to these legs. I can take a look at the stress. So I'm at 58, almost 59. And then in my second, I'm about just about the same. So I didn't increase stress much at all, but I did increase the deformation. And this, I can see the, I could go through and see the results of the modal analysis. It did change my modal results a bit. The thermal would stay, of course, the same because I didn't make any changes to that portion of the body. But as you can see, it's really, really easy to create a brand new design study. Now, the second design study has told me that I'm getting a little bit more deformation out of this than I'm comfortable with. So maybe I want to do a what if analysis. I want to know what would happen if I, instead of 3D printing these legs, left them at the thin level. But instead of 3D printing, I want to know what would happen if I change these to, say, titanium. Maybe I've got some spare titanium hanging around. Piece of cake. All I have to do, make sure I'm in my design study 2, left click, control, left click, left click, left click, come up here. Oh, I'm sorry, and not design, I had to be in assembly, so let's grab those again. Click, 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 and change them to titanium. But wait a second. If I go and change these to titanium, I lose the information from my design study 2. So I don't want to do that. Well, all I have to do is come here and right click on design study 2, click copy. It takes creates an exact copy of design study 2, and I can come to here to the assembly, click here, control click the rest of these, come to my materials, grab those as titanium, apply to selected parts, click OK. Now my arms here, just to double check, sure enough, are titanium. I still have the integrity of design study 2, but I now come to design study 3, come to structural, run that, come to modal, run that, and come to thermal, run that. And now I have a completely new what if design study, and I could even come here and rename these. So I could say, this is my baseline, this is my thinner legs, this is my thinner legs in titanium. And I could keep going down and do what if studies all the way down until I settled on a design that I'm happy with. And these bookmarks are the key to comparison. I come to my bookmark. There's my initial, which I said was 0.5 millimeter, 2 millimeters on my thinner but 3D printed legs, and back to 0.5 millimeter on my thinner legs made out of titanium. So had I not been, had I just sat here and done this and not talked through the entire thing, I could have gone from a completely blank screen to 3 studies, a baseline study, a modified study, and a what if study, all in a matter of, say, 5 minutes. That's the strength, that's the power of SimSolid. Crazy fast analysis and reliable analysis. SimSolid isn't just guessing at stresses, isn't using an untrue method or an untried method. It has taken decades and decades and decades of FE experience, of the FE method, and it has generalized the results from that and applied them in a way that it now can take those generalized results and apply them to geometry. And that's where it gets its speed. But it doesn't sacrifice the quality, the accuracy to get the speed. I'll admit it. I'm the first one to admit. Norman said I've been doing this for 30 years now. I'll admit I was a skeptic. It was a huge paradigm shift for me. Somebody came along and said, "Hey, what you've been doing for decades, now we're going to change that, and we're going to have you do it in an entirely different way." And the first thing I said was, "No way." But I spent some time and I did some analyses and I did some comparisons, and sure enough, the results coming from this are directly relatable. Very, very, very close enough that you can consider them identical. The results are the same. The results are believable. The results are accurate. We can trust this, and we can get insanely accurate results, and we can get it insanely fast. And I said, I did a couple of the relatively easy stuff, but we've got some nonlinear analysis. We've got some transient analysis. There's a ton of things that SimSolid can do. It can help you out. We can help you out. But don't just take our word for it. I would never say, I'm selling the software, take my word for it. I hope you do. But one thing, especially when we're talking about kind of a revolutionary new technology, people want to know, well, who else is using it? Have they seen success? Have they seen accuracy? Have they seen results? I will tell you that SimSolid is one of, if not the fastest growing softwares in our entire suite of tools. It is being adopted by companies all over. I have taught companies, Rolls-Royce, the automotive companies, Renault is using it. There's a ton of companies that are adopting SimSolid because of the speed. They're not taking and replacing their current design capabilities, they're supplementing it. And the capabilities, things that can be handled in SimSolid, are being handled in SimSolid. Well, one of our greatest success stories, a company by the name of Don Burr, they were gracious enough to provide us with a case study, a success story. And what I want you to do, if you bear with me, we've got a 3.5-minute video, and one of the guys at Don Burr is going to talk to you about their success with it and how it helped them out, and hopefully that will allow you to understand and not just take my word for it, but realize that there's industries out there, there are corporations or people who are paying money for the software who trust it and are having results with it. So I've got a quick 3.5-minute video. Once it's done, I'll come back and we're going to talk about how you can get your hands on SimSolid through a software sponsorship. So enjoy the video, and I'll be back in about 3.5 minutes.
We are manufacturers of commercial vehicle bodywork, and what that means is that we design and manufacture from scratch semi-articulated trailers and the bodywork that fits onto rigid chassis. We are known as the innovators in the industry, so we continually have to push the boundaries of what we can produce for our customers. Our engineering team, all of which using SolidWorks, a core engineering product, use simulation on a reasonably regular basis to be able to test out various different types of product. I think some of the problems that we've had with the SolidWorks package inherently is the time spent to be able to set up the models and the simulation runs. And not just that, it's actually the running time itself. So the way in which even the most powerful computers that we can invest in still have difficulties in being able to process those meshes and being able to process the models that we're running through them. The team's first impression of SimSolid was disbelief. And some of the claims were really a bit fantastical, and I think to a large degree we wanted proof of that. We needed to be able to assess the software and go forward from there. And it was staggering. It was staggeringly fast, both in terms of setup and in terms of processing. A good example of the time difference would be something like an underrun bar, or what general people might know as a bumper. And effectively we're testing the stresses and strains on impacts and various different twists in the chassis. So typically on SolidWorks it might be a setup of approximately half a day roughly to be able to process that. And the actual processing time to be able to run the simulation might be in the region of maybe 2 to 3 hours. So in contrast to that, SimSolid might only take half an hour to an hour to set up in the first place, and in terms of processing time, it might take 20 seconds to run that software and be able to provide the kind of solutions that we're looking for. So there is a marked difference, fantastic difference. We took the SimSolid results and were able to submit those results to the DVSA, who then physically tested it, and we found that they were within approximately 1 millimetre of the deflection that had actually happened. So it was a really, really good tool for us. We certainly wouldn't stop using what we've already got. It's inherent with the way that we do things. It's inherent with other product suites that we have on site. So we wouldn't be able to turn away from it. But the SimSolid software has been able to act as a bolt-on. It's a very simple bolt-on, and the integration has been seamless. SimSolid has been able to release resources that we would have otherwise spent on different projects. So what we're able to do is reallocate those resources so that it's more effectively used on other projects. But what it really means is the fact that we can expand on that investigation for a particular sub-assembly, for instance. So if we look at a lifting deck, for example, it's not restricted to running maybe 1 or 2 different scenarios. We can run multiple scenarios on multiple different products to try and find the best possible solution for our customers. I think my response to other companies who are considering using SimSolid would be that we found it quite a staggering product. We were quite surprised, or significantly surprised, at the results that came out. And I think we would say to anyone else that was considering it, you really do need to evaluate this product. It does offer real value.
Yeah, so there you have it, and it's always nice to see that I'm not the only one who first considered their claims staggering or fantastical. I believe you referred to it as. Like I said, it's a paradigm shift. It's a change from what we're used to into the way that we can do things in the future, and they had tremendous success with it. Many companies are having tremendous success from it. An example that I worked directly with, a company was doing modal analyses on large, very, very large, very complex parts. And it would take them hours, 3-4 hours, to prepare the geometry for a modal analysis. And then the modal analysis itself was taking somewhere in the neighborhood of 13 hours to do. With SimSolid, as he mentioned, the setup is so insanely easy, especially for a modal analysis. Brought it in, assigned materials, set it off. It was basically zero time. And it took 16 minutes to run that modal analysis. His took 20 seconds. This was a very complex model, but we went from 17 hours of combined analysis and setup time to 16 minutes, and that's normal. That's not exceptional. That's normal. They're going from hours to 20 seconds. So give it a try. It's worth taking a look at. Let us help you. If you need help with it, we'd love to help you out with it. And of course, the key to that is our corporate sponsorships of competitive design teams. And the pathway to the corporate sponsorship is to pop on over to altairuniversity.com. So altairuniversity.com is our pathway. It's our centralized repository of everything that relates to our educational endeavors. And Altair is very involved with education. And in here, of course, the very first thing you see is this big button, free student edition. Absolutely don't hesitate to get your hands on that. The student edition is great. The student edition allows you access to a number of our different products, Inspire, being one of the ones that's most widely used, and HyperMesh, OptiStruct, some other softwares of ours. There are some limitations on some of the softwares to keep them used in an academic environment. And the Inspire software is usually about a point release behind to make it compatible with the student version. And unfortunately, SimSolid is not included in the student edition. I hope it someday soon will be, but at the moment it's not. The only other option is a 15 15-day license, or the preferred option for competitive design teams is to come here to students. And right down here, you see student competitions, check out our sponsoring. We'll pop in that in a second. I'm going to show you how easy it is to get a sponsorship from Altair. But this also is showing you the repository of all of the information that we have. So we have a ton of ebooks on all sorts of different topics. They are free to get. And they'll expand your knowledge in many different things: electromagnetic simulation, aerodynamic analysis, thermal analysis, fatigue analysis, all sorts of things. And we've got online learning and certification, learn from our users, project lab, interesting projects, to even looking into becoming a software ambassador from us. Let us give you stuff and brag about our software a little bit. But right here, student competitions. You come to that, and sure enough, right here, Eco Marathon. Like I said, we're a very, very proud sponsor of the Shell Eco Marathon. Come to request sponsorship, and this is it. This is all you have to fill out. It's a simple form, usually done by your team liaison or the team captain. We want to know who you are, how to get in touch with you, your college, your name, website, and who your faculty advisor is. Get in touch with us. We will through this. We'll get back in touch with you. There's going to be some paperwork that has to be signed, some legal documentation. But what you're going to get out of it is you're going to get a full license of the software, the exact same license of the software that our corporate users are going to get, and you're going to get as many copies of that license as you need. You got one person on the team running analysis, we'll give you one license. You got 3 people, we'll give you 3. You've got 25 people on your team who all want to play around with SimSolid, which is included with it because it's a full corporate license. We'll give you 25 licenses. And then next week you do a recruiting drive, you get 5 more, you email us and we'll get you 5 more. But beyond just getting the licenses, we're going to provide you support. We're going to provide you a contact. If possible, we're going to get out there. We're going to visit you, do trainings, help you out, do mentoring. We'll help you so that when we all get back together live and all of this COVID nonsense is behind us and we're competing live again, you can drive into next year's competition with a vehicle that is better performance, that's lighter, that's stronger, and brings you closer to winning everything that you want to win at the competitions. So let us help you. Pop on in, get a corporate sponsorship. I call it an application. It's really not an application. You just sign up and you're automatically granted the sponsorship once we get some paperwork done. But we would love to help you out. We'd love to work with you, and we'd love to show you how SimSolid and all of our softwares can help you improve your designs and prepare you for your ultimate career, because these are the tools that companies are using out there. So with that being said, I'm going to pass the baton back to Norman, and he'll kick off this segment that has come to be informally known as Let's Stump Eric, and see what kind of questions. I'm sure there's some great questions out there. So take it, Norman, and let's see what they've come up with.
Yeah, I'm sure you will be handling it very, very well. Thanks so much, Eric, for your presentation and the very hands-on tutorial on how to use the software. So thanks for that. And again, everybody, this is your chance to ask questions. If you want to know anything about the Altair support to the Shell Eco Marathon teams or about the software in particular, please send us your questions now. Send them either on menti.com. You see the number or the passcode on the screen, or put them into the comment box on YouTube. First, I think the first questions relate, Eric, around the interface that is quite different from Inspire, what you showed us yesterday. Do you plan to update SimSolid to match the Inspire interface, or why is there this difference?
Excellent question. So I will say that SimSolid was not originally developed by Altair. It was an acquisition. Our management, our CEO, is always out there keeping his pulse, or keeping his finger on the pulse of technology, looking out for amazing new technologies, and discovered SimSolid and felt that it would be an absolutely fantastic addition to our portfolio. And fortunately, we were able to work out an acquisition of of the technology and acquisition of the company, and so it became part of the Altair software. But that's why the interface looks so different. It was separately developed. That being said, there have been some changes to the interface, and pretty much all of our softwares are in the process of being ported over to the Inspire interface. So I would have to imagine that sometime in the future it will. I don't know the time frame from that, don't know 100% certain, but with everything else moving over to it, I can see it doing it. But even in the interim, one of the nifty things is if you're an Inspire user, if you go into the settings Inspire and the run options, you have the option to change the solver from OptiStruct to SimSolid. And effectively, then you get the interface of Inspire with the speed of analysis of SimSolid, so you're getting the best of both worlds. So we can run the analysis directly from within Inspire by switching that over. Of course, that only applies to structural simulation. There is no optimization capability within within SimSolid. So with that, you'll be using the OptiStruct engine. But that's our short-term fix to providing the ease of use of Inspire with the incredible speed and accuracy of the SimSolid solver.
Mhm. And the question that is very closely related is, could you summarize somehow what is the main difference between SimSolid and the Inspire Studio software that you talked about yesterday?
Excellent. So Inspire, with many of our softwares, there's a lot of similarities. There's some differences. There's some overlap in technology. So they both do linear static analyses, and they both do them. The setup is relatively easy. Inspire has a slightly different setup that some people like, and like I said, you can use the SimSolid solver in that case. Inspire does modal analysis. Inspire does thermal load, but not thermal transfer. But then there are things that each one of them do very well and do on their own. So SimSolid does have a broader range of analysis capability. It does do nonlinear transient analysis. It does heat flow analysis, not just heat as a load. And then Inspire has the capability to do optimization, multi-body motion analysis, and the combination or the linking of the motion and analysis and optimization. So while there is a bit of overlap in technology or capability, there are things that both of them can do independently that the other can't. And in an ideal world, ultimately those two will merge together and we'll have one combined product that has the power and capacity to do all of them. That's my dream for the future. I don't know where we stand on something like that, but right now they work well together.
Okay. Another question that's been asked here is, what's the difference between the linear and non-linear structural solver?
Okay. So both of them are going to be done. Well, OptiStruct, for instance, does both of them implicitly. I don't know how the technology behind SimSolid's nonlinear capabilities, but the general difference between linear and nonlinear is, first of all, so we'll start with a linear static analysis. The part has to be held in place, and we have to deal solely with material in the linear range. So assuming back to mechanics of materials, we're talking about the elastic portion of the stress strain curve. When you push on it and it goes back to its original shape. Think elastic, an elastic, a rubber band. You pull on it, you let go, it goes back to its original shape. So those are the assumptions that are made for a linear static analysis. Nonlinear, you've got two types of nonlinearity. You've got geometric nonlinearity and material nonlinearity. Geometric nonlinearity is when there is not a linear relationship or there's not a linear load going on there. And that means that for linear, we generally are dealing with things that are very small deformation. And the reason why, think of a diving board, for instance. If I apply a very small amount of force to a diving board, it's going to move just a little bit and it's a linear relationship. But if I apply a force to a diving board and I continue to push it down, that diving board is going to begin to bend, and that force that I have on it is actually changing orientation, that's a nonlinear situation because no longer am I applying just a single linear load. So that's geometric nonlinearity. The way that it's solved is slightly different. We have to follow the change in geometry. But in general, if we're talking very small, relatively small deformations with a standard linear material, that's linear static. And when we're talking large deformations or a nonlinear material, that would be nonlinear analysis.
Okay. And again, a performance question here on the software. So other than the meshless system being quicker and easier to use, what other drawbacks or advantages does this software have compared with other FEA software?
So from an advantage standpoint, the big advantage is the speed. The disadvantage to it is it is limited in its ability. There are some things that we can't do. For instance, at least at the moment, we can't look inside the part. I'm seeing the stresses on it, but I don't have the ability to retrieve the stresses from inside the solid geometry. It's strictly on the surface representation, which is great. It gives us all the information we need to know, but I can't look inside there. Another limitation is the same limitation as Inspire. I don't have the ability to do composite analysis with it yet. But I would say that with every single analysis tool out there, there are going to be advantages and disadvantages. There are going to be things that it can do quite well and things that it just plain can't do at all. And as long as we're dealing with something that falls within the capacity of its solution, then it's a phenomenal software, and the speed and ease of use trump anything that might be considered a disadvantage to it.
Yeah, and one of our viewers is also asking if you could elaborate a bit on which cases you think is it better to use SimSolid than HyperMesh, or maybe even the other way around.
Yeah, so I would say that any analysis that falls within the capacity to do in SimSolid, do it in SimSolid. It's going to save you a ton of time. You're going to be doing things, and this, mind you, this is coming from somebody who has created thousands of meshes over decades. So it's not easy for me to say, move away from my beloved HyperMesh. I've been using that for a very long time. But if it's within the capability of doing in SimSolid, absolutely, you're going to save your time. You're going to, it would almost be considered wasting time to do something more complex or in a more complex manner. But why would I use HyperMesh over SimSolid? Because where SimSolid does this amount very, very well and very fast, HyperMesh and OptiStruct have the capacity to do this amount. So if I'm falling within that sliver of capability or that region of capability, use SimSolid. But if I need to move out of that, and there are many, many, many times I need to move out of that, then you're going to be using our full products. You may be able to use Inspire, which is substantially easier to use than HyperMesh because it's got a bit of a broader range of things that it can do, but HyperMesh is going to have this amount of things that it can do. So if you can get it into that slot of capability, go with the easier product.
And our viewers are particularly intrigued by the speed, and there's one question here. Could you elaborate on how SimSolid gets its speed and, importantly, its accuracy despite being meshless?
Because it's based on FEM technology, finite element method technology. So that's where it's going to get its accuracy. Where it's going to get its speed, because of the algorithms that they've developed to generalize the FEM method, it's able to apply essentially past knowledge to new geometry. And I'm just dancing on the edge of talking about things that I truly don't understand. I mean, the mathematics behind it are well beyond me. But my understanding is because it's a generalization of the finite element method, they're able to make predictions and assumptions based upon tried and true FEM method. They can apply that to the geometry and essentially derive a very accurate result without having to re-derive it.
That's clear. Thank you very much. Again, a reminder to all of you, we're already on the top of the hour, but we still have time left. So please send us your questions, get them in through menti.com or in the comment box in YouTube. This is your chance to ask any questions about SimSolid or the student sponsorship program that Altair has. A question here for you, Eric. Is the solving time depending on the processing power of the PC on which the software is run?
Yes, there absolutely is that. The processing power of the PC is going to determine how many mathematical calculations per second or millisecond you can do. So there's no getting away from that. But considering the speed at which SimSolid goes, if I take 3 times the amount of analysis time, well, then I just took my analysis from 6 seconds to 18 seconds. So we're not we're talking about times that are so short that even if I'm tripling, quadrupling it, we're not talking about a tremendous increase in time. So you don't have to worry about having a super high-end computer like you would normally have with, or we normally have to with a mesh-based system, where a tripling of time could take you from 10 minutes to a half an hour, or from a half an hour to an hour and a half, or even longer. So an increase in time isn't a massive increase in time, because we're talking about such short times to begin with. And one other thing worth mentioning is, and I meant to mention this in the previous answer, when it comes to accuracy, NAFEMS. So NAFEMS handles a lot of the standards out there. And one of the things they do is they always do accuracy tests. They have standard models that they compare analyses that are done in solvers to known answers. And they published an article in this past January where they said, and I quote, they were very happy with the accuracy of SimSolid. So if the standards committee, the ones who sign off on the accuracy of solvers, are very happy with the accuracy of the results, that's enough to ease my concern. So.
Okay. We have a very specific question from one of our viewers saying, I'm having trouble downloading the student version of Altair products. Who can I talk to? And maybe you want to say also something, why would they want to get the student version if they can have the sponsored version?
Yeah, well, the one advantage to the student version is that's going to get you the software pretty much immediately. And we've had a lot of people who do that, who do the student version, because it's going to take probably a week or so to get everything. And especially now in this separation that we have, maybe getting the paperwork signed by your faculty advisor might take a little bit of time. But so there's no harm in getting the student version if you want to get working on things now, or if you're really intrigued with SimSolid, you can get an automatic 15-day license and start playing around with it now, and tide you over until we can get you the corporate sponsorship. But the corporate sponsorship is going to be the ultimate goal to that, because it's going to get you the best, most robust solver. But to tackle the initial part of that question, I'd need to know what issues you're having. Please feel free to get in touch with me. My email address is just my name. It always appears there at the bottom. It's just Eric, ERIK, at Altair.com. Drop me an email, and if I can't help you directly, I'll make sure to point you in the direction of somebody who's going to give you a hand downloading that student version of the license. But we'll give you a hand. But yeah, do get the corporate sponsorship for the team. That's going to get you an even better license. So.
Thanks for the offer to help out here specifically. Another question, very specific about the usage of the software. With the software, is it possible to see the displacement result of a random point in the model?
Actually, yeah. So if I can come back up here to my screen here, let me open up my displacement results here. And what I can do is, nope, not that one right there. Where is it? It's one of these in here. Not that. My dialog controls. I know I've got it. See, now you're. Is this it here? Nope, this one is. I knew it was around here somewhere. So what I can do is pick a point. So I can pick that point right there, and there's my result. And you can see I get a ton of information about that result, not just the displacement magnitude. So that point is, I get its coordinates, its displacement, all of the possible values of the results that we have there. And I can pick multiple of them. I get results for all of them, and I can save this to a CSV. So I can export these out as well.
Okay, thank you very much. Where would we find tutorials to use softwares that Altair provides, like SimSolid?
So if you go to the Altair University website, we've got a ton of educational materials on there. We've got tutorials, we have videos, we've got a whole bunch of information. But again, and I know I'm going to sound like a broken record here, if you get that sponsorship, that's kind of our pathway to know to you and your pathway directly to us. You can contact us. In a lot of cases, it's going to be me you're going to talk to. I can get you videos on it. I can get you the training material. We can even arrange custom trainings, virtual for now, but ultimately in-person trainings. So in the interim, definitely visit altairuniversity.com. It's our portal for all knowledge that we can provide. But in the long term, get that sponsorship, and we can directly help you.
Okay, thank you. And last reminder here, we have 2 or 3 questions left for you. Eric, this is your chance to get in any last-minute questions. Type them in now. If anything is weighing on your mind about the use of SimSolid or any information about the student sponsorship program from Altair. One of our viewers is asking, Eric, is SimSolid a suitable program to perform analysis on tubes?
I don't see why not. Absolutely. I've never done it personally or directly, but I don't see any possible reason why it would have an issue with a tube.
And again, we're getting related to this also often here material questions, and I think you've answered it before, but maybe you want to explain also a bit why and what is maybe a workaround. Does the Altair software work on composite materials?
Yep. So yes, I did mention that we don't, but I'm glad you asked that question because it'll allow me to elaborate how we can work with composites. So we don't directly work with composites because a composite material is going to be a layup of plies with each of them having their own individual behavior. We don't have the ability to define a material that way, but that's not to say that people are not using it to analyze parts made out of composites. What they're essentially going to do is they're going to homogenize that. They're going to take those layups where I'm going to apply and apply and apply and apply, and they're going to consider it a stack and view the material, the mechanical behavior of that entire stack then as an individual unique material, put the properties in there, and then analyze it, and then take the results of that analysis and then relate it back to actually creating a composite ply or layup. So yes, Norman, I appreciate you asking that question. Yeah.
Thank you. And we have a question on transient forces. Can I set a time for which the force is applied, and if it's ramped, to check the deformation at each of the time steps?
Yeah, so unfortunately, I can't talk directly to that because I have yet not run a transient analysis in SimSolid, but we do have the transient capability. It will be a force applied over time, and then we're going to get results based over time as well. So I think it was like the third icon over. It was the transient analysis, and that's a time-based load. So yes.
Mm-hmm. And I have a last question here for you, and this is maybe the ultimate question for any simulation or for any simulation tool. How do I know my results are correct?
Because I said so.
No, okay, well that is of course compelling.
No, and that's a great question, and it's a question that every analyst should absolutely ask themselves every time they do an analysis. And all I can say is this: first of all, your results are as correct as the setup that you made. Any analysis tool out there, whether it's ours or any of our competitors, and don't tell anybody I said this, but any proper commercially available analysis tool with a properly set up model is going to give you the correct result. And when we say correct in FEA, we're talking very, very close. Nothing is 100% in FEA. The world, everything is too chaotic. Everything, there's too many variables to truly answer every question 100% correctly. But we're within that band of uncertainty that makes us confident in our results. The problems come in typically with errors in setup, and it's very, very easy to make a mistake when you're setting up an analysis. Some of our softwares, Inspire and SimSolid, make it much more difficult to make a mistake, but nothing is truly mistake-proof. We're dealing with very large numbers. Young's moduli can be in the range of e to the 9. That's a lot of zeros, and very easy to leave one or two of them off. So trust in the software. There's a term, trust but verify. Trust in the software because we're behind the scenes making sure the software is accurate. We wouldn't release it if it were not accurate. But always trust your gut. As an analyst, you're going to have expectations of behavior when you go in to do an analysis. I've run thousands of analyses, and in each and every one of them, I had an expectation of a result. In a large portion of them, I was relatively correct in my assumptions. But every once in a while, I'd get a result that just totally kind of blew me away or was outside of what I was predicting. Trust your gut. If you get a result that isn't what you're expecting, don't just blindly believe the software, whether it's ours or anyone's. Take a look at your setup. Make sure you didn't leave a zero off. Make sure you aligned your loads properly. Make sure, go back and verify everything you did. And if you did it all correctly, then trust the results and realize that, yeah, this is not what I was expecting, but it's correct. It happens. But a lot of times you may find you made a mistake. So make sure your setup is correct. Make sure your geometry is correct, and our results or anybody's results are going to come in, and they're going to give you very accurate results and great information to engineer from.
Thanks, Eric. And I have bad news for you. I lied to you. This was not the last question because we had a couple last minute ones come in, and I just want to ask for clarification. Obviously, we heard your answer about materials. What about honeycomb materials?
So in the case of a honeycomb material, I've seen it done a couple of different ways, and I've worked with some honeycomb materials where people have actually physically modeled the honeycomb and then applied the material property of the honeycomb of the actual material that makes up the honeycomb and applied that to that. Or I've also seen people who have taken, again, kind of like we were talking about with composites, who've taken kind of a homogeneous view of it, taken the behavior of that and homogenized it into material behavior, and then just model it as a consistent material. So you can either go with the physical modeling approach, or you can go with the homogenization approach. I've seen successful results, accurate results with both of those.
Oh, that's clear. And I guess very last question indeed. Can I apply with my team to the sponsorship program at any given time?
Absolutely. In fact, I'll wait. Go ahead and take care of it right now. No, just yeah, you can do it anytime. You can do it now. You can do it tomorrow. You can do it over the summer. We don't take the summer off. We don't take time off. We'll be there. We will happily process your sponsorship and get back to you no matter when you want to do it.
Thanks very much, Eric. And it is reassuring to hear that latest in time for the start of the new season. In fall this year, everybody should have the software they need. And again, there is no reason to hesitate not to get in touch with you. I would like to thank you so much for taking the time with us today and to answering all this question, and for your very, very hands-on tutorial that you gave us. So huge thank you to you and the whole Altair team for supporting us here today, and of course the last 4 years of Shell Eco Marathon worldwide. I'd like to also thank the students for tuning in and taking part in the webcast tonight. There are more virtual learning sessions coming up in May. Tomorrow, we, for instance, will be hearing from Paul Over, who is a student of Hamburg University of Technology, as well as an Altair student ambassador. He'll be talking to us about lower energy consumption and better performance with optimized aerodynamics, so very much a topic for all our Shell Eco Marathon teams. If you haven't registered yet for this webcast, so please go to our website and register. We would love to have you to join tomorrow for another Altair presentation. Before we close tonight, I'm still very excited to tell you that tonight, for the very first time, the Shell Eco Marathon Americas Off-Track Award winners will be announced live and exclusive on Instagram and Twitter. We have been getting the jury together to judge the Off-Track Award submissions. Lots of submissions came in, over 60 submissions for the Off-Track Awards, and the jury has made a decision. So please join me at 6 p.m. Eastern Daylight Time for a virtual award ceremony where I will be joined by a select panel of judges and a very special guest, the Shell Pennzoil NASCAR driver, Joey Logano. Together, we will recognize the excellence and outstanding achievements of all of you and your peers, and announce, of course, the winners of the 2020 Shell Eco Marathon Off-Track Awards. So make sure you follow us on the Shell Eco Marathon Instagram or Twitter to see the results. 6 o'clock p.m. Eastern Daylight Time. And with that, that's all for today. Thank you and goodbye.